So, guys, alright, so we just finished the introduction to Solidity. It's pretty comprehensive. We covered Learn Web3.io, covered all of the functions, variables, state variables, local variables, and now we're going to write and deploy a simple smart contract in DApp using the Remix ID. So let's see how we're going to do this. Yes, build your first DApp on Ethereum. Step-by-step tutorial. So we're going to create a simple front end, deploy a Solidity smart contract, and connect them together using MetaMask, Remix, and viem. I've not heard of that. Okay, what's that? By the end of this tutorial, you'll be able to create a simple front end with two buttons that can interact with smart contract functions. Right, perfect, sounds amazing. So we're creating a basic HTML, basic Solidity smart contract, and we're connecting the web page with the smart contracts using viem. Perfect. So it's a TypeScript interface, basically. Alright. MetaMask, I already have it downloaded and set up, but if you don't, you can download and set up MetaMask. Alright, so now we're going to the Sepolia Test network. Sepolia, you can search for Sepolia, not ZK saying Sepolia. We need Sepolia Test network. Right, I don't have Sepolia ETH, so this is the testnet. It's not real money. Now we need some ETH. So this is, and then send the ETH to my dev account. Oh, I already have some ETH on my personal address. Lovely. So yeah, if you guys need some ETH on Sepolia, you can reach out to me too if you're having any difficulties with this. I'm gonna send 0.142 ETH to my dev account. Alright. I have ETH on my dev account. That's done. We don't need all this anymore. Let's get to this later. Okay. So we have our ETH, and we've received ETH from one of the faucets. Okay. Install a code editor. So this code editor is where you type in your code, edit your code. Visual Studio Code is what many people use. I have Visual Studio Code already installed, so I'm gonna go ahead and open that up. Let's open new file. Close all of this. That's how the UI looks like. Open folder. No, that's not right to the things I know. Right. Install Node.js if you don't have already. I believe I have Node.js installed already, but you can just copy this. Install Node.js if you don't have already. Open up a terminal. Command prompt on Windows, terminal on macOS. So, computer called First DApp, open that folder and your code editor. Either if you're using this one, right click, or navigate to the folder using your terminal in VS Code. Right, so let's go ahead and create a new folder here. Rename this to First DApp. Okay. Now I'm gonna open this folder in VS Code. How do we do that? That's open. Yeah, we can do that through your open folder. Desktop, First DApp. Okay. So now we have First DApp open here. Okay. Now we're going to open up this folder in VS Code. Yeah, we've done that. Okay. Now we're going to create a new file, index.html. And this is a basic boilerplate text that's there in the HTML. It has some definitions, what the title is, all of that. Okay. So I'm going to go to our Visual Studio Code, new file, and file HTML, index.html. Okay. Inside the body, we're adding this code. This is my DApp where we can input get mood, set mood. Alright, where it's a simple smart contract where we're reading and writing a value to and from the Sepolia Testnet. Right, so this is the body. There's a few buttons we're creating to get mood and set mood. There's some CSS, the styling language. We're adding it inside the head tag over here. Some fonts, directions, width, etc. Save this file. Okay. So let's update our body tag. This. Okay. And now we're adding this under the head. Okay. Like this. So we've added the style under the CSS and the head. Okay, and our index.html is ready. Okay, now control plus this tilde is what brings up the terminal. Okay, control plus this. Okay, we have our terminal. And now light server. Okay, let's see if this works. Alright, our light server is not installed. That's an issue. Is it installed? Let's see now. Make this a little bigger. Error. Operation is rejected by. Google what this error is. Sudo npm install. Okay, let's add sudo. Looks like it's working now. Alright, so that's installed. And now we start running our light server. Okay, so it's running and then boom, that's our HTML code up and running. So now we need to look at the smart contract. Okay, so can use any editor, but we're using Remix. Remix is an online IDE that can use. So I'm gonna go ahead and open up Remix IDE. Let's search for that. Make sure the links you're clicking on are always safe. With Web3, it's dangerous. One wrong click, your wallets will get drained. So be careful. All right. So this is our. Gonna create a new file. I'm gonna call this move.solve. Alright, and let's copy this. This is a mood diary, contract code, function set mood. This is a temporary string only for this function that we're passing in, and we're setting the mood variable over here equal to whatever's being passed in. Get mood, we're returning whatever mood is stored in this variable already. So that's the smart contract. Okay, yeah, it's a very basic smart contract. We're ready to deploy. Remember, now you need to deploy this smart contract. It's on the Sepolia Testnet network. Going to MetaMask is on Sepolia already. We have some ETH in it. Now, what you need to do is compile the code. So click on the Solidity compiler. You can choose which version is going to compile, deploy the code. Alright, so now we're in this compile section. Our version of Solidity here is different from what's specified here, so I'm going to change it over here to Hope I'm doing something correct. And okay, so we compile this code. Alright, and now it's compiled. What do you do next? Deploy the contract under the deploy and run transactions tab. So we come to the deploy and run transactions tab. And which environment are we using? We are using the inject provider MetaMask, right? So click on injected provider. Okay, it's compiled. Alright, that seems to have fixed it. So injected provider, now we're connected. We can see our ETH balance 0.142 ETH. Yep, and we're ready to deploy. And this is a transaction that happens, so you need to pay for this transaction, paying some ETH, confirm. You can see this on the block explorer too. You can see this transaction being confirmed. So this is your first smart contract that you're deploying. Once this goes through your transaction, we deployed, and you'll get a transaction hash. This is the transaction hash that you see here on the block explorer too. Confirm the deployment. Take note of the address and API of the contract you just deployed. We will need this on our front end. For doing this, you can copy the contract address by clicking copy. Right. Transactions recorded here. Alright, so here is where you can find our mode diary contract has been deployed. We copy this address, and I'm going to note it down here. And copy the ABI under the contract in Remix's compile tab. So we come to Remix compile tab, ABI. Copy the ABI, paste it here. Now you connect your web page to your smart contract. Now let's go back to HTML, index.html. We're adding viem as an external library to your code. Use viem to create references to the deployed Solidity contract and call your contracts functions through MetaMask with the help of viem. So at the beginning or end of your HTML file, create a script tag and declare two variables there. Right. So get mode, set mode are the two variables. This is a file. Smaller. Okay. So end of this beginning or end of HTML. So this is the end of the HTML file. The next script will be importing and using viem, which is a library for interacting with smart contracts. So this is one script for defining the variables. Then this next script we're importing and using viem. Script library module. It's an interface. Wallet client. Okay, it's an interface to interact with Ethereum accounts. Create wallet client. Sets up a wallet client with a given medium. Okay. Copy this. Paste this in. And below the code we just wrote, we'll be creating a wallet client which will enable our app to connect to the user's account. To Ethereum. So okay, this wording is in a way, but basically your app can connect to the user's account. If a new user comes in, they can connect, our app can connect to their account. So go in this other block is mentioned here. We've created a wallet client. Create a client that connects the user account. Okay. Change Sepolia transport. Custom window.ethereum. So here we're connecting the user account to Sepolia. Now this, making your wallet extension, shows a pop-up to connect your wallet. Accounts equal to await wallet client dot request addresses. We're getting the first address in the accounts array. User might have multiple accounts. We're getting the first address. We place the following two values. Make sure the mode contract address is in /single quotes. Alright, so this is the details we have from our previous step. Alright, let's copy the contract address and replace it here. And let's copy the API. And just plug it in here. Right, so that's it. There's this section where we could understand what API is later, but this is just what we've been doing with viem. So we define these variables. We use this create wallet client. And then we create a wallet client that connects to the user account. So this create wallet client is what's helping us to connect to the user accounts. We created a client and for the Sepolia window, and now we've requested the address using a pop-up window. For the contract API, we want to specifically navigate to the JSON section and describe our smart contract in JSON format. Since we have two functions in our contract, this should be an array with two objects. Alright, got it. So your API will have an array with two functions in it. Sorry, an API will have two functions in the contract. So the array will have two objects. Okay, two objects. Yeah, this is the first object, and then this is the second object for the second function. Set node, we describe each field below. Name, set node. So this object, we're describing the object. Each object inside the array should have the following fields: constants, inputs, names, outputs, payables, state, mutability, and time. So just remember these. For each function, they're having this set node function. We describe each field with name, set node type function, and outputs, nothing. State mutability, it's non-payable because this function does not accept either. If it accepts either, then payable, I believe. Inputs, this is an array of inputs to the function. Each object in the array should have internal type, name, and type. Array of inputs to the function. So internal type is string, name is underscore move, and again there's a type, that is string, internal type and type. Get mode, outputs, same type as internal type, name and type should be string. Name is not defined because it's memory returnable, and string respectively. State mutability, this is view because this is a view function, and this has no argument, so this should be just blue. So this is how the end result looks like. Const node contract API, const node contract API equal to, let's copy this because it's formatted better. Two kinds of objects for two functions. The inputs, what are the inputs? Defining the type of the inputs, the name, state, mutability, all of that, right? Perfect. Next in your code, create an instance of your contract so that you can interact with it using your, so this is const node contract instance. You can get contract addresses, store your APIs here, client, wallet client. Alright, we're gonna do that. So an instance of the smart contract is created. Now we can create assigned values to get mode and set mode. They will be JavaScript functions for calling the two respective smart contract functions. So we support defined as async functions. Since get mode in our contract is a read function, const mode equal to await mode contract dot instance dot read dot get mode. So this is a read function that we're defining, and we're calling get mode function that's defined in the contract. Document dot get element by ID, show mode dot inner text onto your mode. Right, so this is the way of displaying it. Your mode. Set mode, const mode equal to document. Alright, so this set mode is a write function, so we need to pay some gas fees. We're pulling this value for mode when we're entering it earlier. Not right. Okay, so the contract instance has a read method and a write method, and here we have our account address. So I didn't understand this address part of it. And so we have our JavaScript functions that we're going to update in here. Alright, and finally update your button such that they call these functions when clicked. Okay, button not clicked. This. Let's go to where our buttons are. We update the buttons. And we're calling get mode and set mode. We click the buttons. So this is our final code. Alright, the first, getting the API, defining the instance. Under the instance, we have the functions defined for reading and writing, and this is the DApp. Script part has come under the body, so does it make a difference? Just move. Not sure if the order makes a difference, but let's see. We can fix that later if needed. Let's try it out. Follow the steps correctly. Your web should now be able to call the get mode. Make sure it's still running. Let's see. Localhost 3000. Okay, it's still running. And now go to your web page and test your functions and approve the transactions as needed through your MetaMask wallet. Open your contract. So console too. Sepolia. Okay, set mode. There's a transaction happening. Confirm, so it looks like the audio is not. Control Shift I. Open the console. Control Shift J. Okay. Command Option G. So that's an error here, I believe. Command Option G. So let's see what was happening here. Failed to load source. Current chain does not match the target chain. Okay. That was the initial. Okay, contract call, set mode happy. Okay. That was the initial errors, but let's get mode. Your mode happy, perfect, seems to be okay. Let's do sad. And that's another transaction too, to set the mode. This was the contract creation. This is where we called the function set mode, set a value for it. And let's do get mode. Yep, so it looks like it's perfectly working, and that's the first DApp that we've created. We've made HTML, we've deployed it, and this is on-chain transactions we're setting and getting the mode. Yes, so it was perfect score. Let's go. That's building a decentralized application.